Here we have a problem on finding domain and range of composition of two functions. Okay, let's go to the question. Find the domain and range of f dot g, which is a composition of two functions f and g, where f of x equals to square root of 4 negative x square and g of x equals to x square. Okay, first let me write the composition of two functions. So that is f dot g. The formula to get the composition of two functions is f of g of x. So this is called composite function. Okay, now to get the domain of a composite function, domain and range of composite function, first we have to identify the first function and second function. So in the given two functions f and g over here, how do you have to identify the first and second function? Okay, here for which function can we give input at first? So here in this composite function g of x, the function g of x is clearly seen. So for this g of x, we can give this x square as input. So we can give input for g of x at first. So this function, this g of x, has to be considered as a first function. Let me write the stuff over here. So we have to assume the function as a first function for which we can give input at first. Okay, now the other function, that is this f, is called the second function. Let me write it over here. Okay, now I just identify the first function and the second function in this composite function. Okay, so you know the domain is nothing but the values of x for which a given function is defined. To get the domain of a composite function, what I have to do is first I have to get the domain of the first function. In this case is g of x. Okay, now let me try to get the domain of the first function, that is g of x. So how do we have to get the domain of the first function g of x? For that we have to look at the first function g of x, that is equal to x square. So what values can we give for x over here in this x square? We can give any real value for x over here, because for any real value of x, this x square is defined. So for all real values of x, the function g of x is defined. So the domain of the first function is that is all real values. Actually, the domain of the composite function is the same as the domain of the first function. In this case, the domain of g of x, that is R, or the domain of the composite function must lie in the domain of the first function. That is, it has to be a subset of the real numbers R. Okay, now for that what we have to do is we have to find the result of the composite function. For that, let's take this stuff over here, f of. So for this g of x, we can plug in the stuff which is equivalent to g of x, it is x square, that is f of x square. Already we know that f of x equal to square root of 4 negative x square. To get the stuff which is equivalent to f of x square, we have to plug in x square for the x over here. Then I'm getting square root of 4 negative x square, the whole square. Okay, now I got the result of the composite function, that is square root of 4 negative x square, the whole square. So now the domain of this composite function is the same as the domain of the first function, that is R, or the domain of the composite function must lie inside the domain of the first function. That is, it has to be a subset of the real numbers, a set of real numbers. Okay, so for that first we have to find the domain of this, the result of the composite function. So actually it is a square root function. Since it's a square root function, the value that we have inside the square root cannot be negative. So always it has to be positive, or it can be 0. So the stuff we have over here can be either 0 or positive, that is greater than 0. So that we can write as 4 negative x square, the whole square, greater than or equal to 0. So this is the domain of the composite function over here. I mean the result of the composite function. Okay, in my next step, what I'm going to do is I'm going to write this 4 as 2 square. Then I'm getting 2 square negative x square, the whole square, greater than or equal to 0. Okay, now this is the difference of two squares. We can factor this expression using an algebraic identity, that is like a square negative b square equals to a positive b times a negative b. So using this identity, we can write the factor form of this expression, because this is in the form of a square negative b square. So like whenever we have a difference of two squares, a square negative b square, it can be written in the factor form a positive b times a negative b. Okay, comparing this and this, at the place of a we get 2, at the place of b we have x square. So then how do you have to write the factor form of this expression over here? A positive b, a means 2 and positive b means that's x square, and a negative b. So 2 negative x square greater than or equal to 0. Okay, here we have product of two binomials on the left side, and the product of these two binomials has to be greater than or equal to 0. Let's consider the first binomial over here. So in this one, this 2 is positive, and here we have positive sign, and here we have x square. Okay, so like whatever real value I consider for x over here, always this x square is positive because of the even exponent over here. Even if I plug in negative value for x over here, when it is squared, it will become positive. Anyways, so this value is always positive, 2 positive x square. So our aim is the product has to be greater than or equal to 0. That means either the product has to be positive or it can be 0. So always this one is 0. Since always the first factor over here is 0, the second factor also must be positive, so that positive times positive, always the product can be positive or it can be 0. So now it's clear that 2 negative x square, the second binomial 2 negative x square has to be greater than or equal to 0, so that when we multiply these two binomials, the product will be greater than or equal to 0. Okay, now let's solve for x in this inequality. So for that I am writing this 2 as square root of 2 the whole square negative x square greater than or equal to 0. So because even if I simplify this one, square root of 2 the whole square root and 2 square will cancel, I'm still getting the original stuff 2. So why I'm writing this 2 as square root of 2 the whole square? In order to get this expression in the form a square negative b square. Okay, now the square root of 2 the whole square negative x square is in the form of a square negative b square. So now what we can do is we can write the factored form of this expression. In that case, I'm getting square root of 2 positive x times square root of 2 negative x greater than or equal to 0. Okay, now so what I'm going to do is, instead of considering this inequality sign, I assume this is equality. Let square root of 2 positive x times square root of 2 negative x equals to 0. Just I assume. So instead of inequality sign, I just assume equal sign. Let's solve for x in this case. So when I solve this equation, like the product of two binomials equals to 0, either the first one has to be 0 or the second one has to be 0. If solving this equation, I'm getting x equals to negative square root of 2, and solving this equation, I'm getting x equals to positive square root of 2. Let me draw a number line. Let me take positive infinity, and here on the left side I have to take negative infinity, and here we have negative square root of 2, and here we have we can take positive square root of 2. So the approximate value of square root of 2 is 1.414. So we can write this one as negative 1.414, and here it's just 1.414. Okay, now so we have I mean the real number line can be split up into three parts, so three intervals. So this is the first interval, this is the second interval, and this is a third interval. Okay, now let me verify the first interval with the inequality we have over here. So let's take a random value in the first interval. Since the value of this negative square root of 2 is negative 1.414, the approximate value can be taken as a negative 3 or negative 2, something like that. When I plug in negative 3 into this inequality for x over here, what will happen? So this is negative 1.414. When x is negative 3, it will be a negative value. Okay, so when I plug in, actually this is positive 1.414. When I take x equals to negative 3, already there is a negative sign over here. So negative times negative will become positive. Anyways, this factor will become positive. So negative times positive will become negative value. So negative value greater than 0 is not true. So the first interval, that is negative infinity to negative square root of 2, will not work. Okay, now let's consider the second interval, that is negative square root of 2 to positive square root of 2. Let's take a random value. So since it's a negative value, it's a positive value, we can take a 0 between them. So when I plug in x equals to 0, it will become positive square root of 2. And when I plug in x equals to 0, this one also become positive square root of 2. When I multiply two positive values, so always it's positive. So yeah, positive value greater than or equal to 0 is true. So this interval works, the second interval. Now anyways, let's verify the third interval as well. So since this value is 1.414, let me take a random value in this interval, 3. So when I plug in x equals to 3 in this one, already this is positive. When x is 3 positive, yeah, positive value, always it's positive. Okay, so the value of this one is 1.414. When I take x equals to 3, so 1.414 negative 3 will become a negative value. So positive value times negative value will become a negative value. Yeah, negative value greater than or equal to 0 is not true. So we can reject the third interval as well. So only this interval works, and we can consider the endpoints also, negative square root of 2 and positive square root of 2, because we have greater than or equal to 0. Even if I plug in negative square root of 2 over here for x, this factor will become 0. When this factor is multiplied by this stuff, it is equal to 0. 0 greater than or equal to 0 can be accepted, because greater than or equal to 0. So both left hand point and right hand point of this interval can be considered. So therefore the domain of the composite function over the result of the composite function is negative square root of 2 comma positive square root of 2. This is the domain of the result of the composite function. Okay, already we got the domain of the first function g of x. It is a set of all real numbers. So as I said earlier, the domain of a composite function can be the same as a domain of the first function, or the domain of the composite function must lie inside the domain of the first function. That is, the domain of the composite function has to be a subset of the domain of the first function. That means the domain of the composite function has to be the subset of the set of real numbers. Okay, so how do you have to conclude this one? So for that, what I'm going to do is I'm going to draw another number line over here. So here I'm taking positive infinity, and here I'm taking negative infinity. So please understand this number line represents a domain. Okay, so here we have, let me mark, because since this is the domain of the result of the composite function, I'm marking negative square root of 2 and positive square root of 2. Okay, now first let's draw the domain of the result of the composite function, that is negative square root of 2 comma positive square root of 2, and please remember these two endpoints are included. So now let me draw it. Since these two endpoints are included, I can take a filled circle over here at negative square root of 2, and also filled circle over at positive square root of 2. So like this is the domain of the result of the composite function. Just now we got it. So any value from negative square root of 2, positive square root of 2 considered for the result of the composite function. What is the domain of the first function g of x? That is all real numbers. All real number means we have to draw the entire interval from negative infinity to positive infinity. Okay, now I have drawn the domain of the result of the composite function, that's over here, and the domain of the first function g of x, that's over here. So what is the common region of the two graphs I have drawn in green color? So this is this part represents the common region of the two graphs, and also the common region of the two graphs gives a domain of the composite function. So this common region that I marked over here gives the interval negative square root of 2 comma positive square root of 2. So this is the domain of the composite function. Okay, now we got the domain of the composite function f dot g. Okay, now let's erase some stuff, and let's start finding the range of the composite function. Okay, now let's see how to find the range of the composite function f dot g. Actually, range is possible values we can have for the function. For example, if I want to find the range of the function f of x, so what values can this f of x possibly take? That's called range. So domain is nothing but the values of x for which the function is defined, and the range is nothing but the values of this f of x. Okay, now to get a range of a composite function, first what I have to do is I have to write the range of the second function. So here already we have discussed that f is a second function in this case. So let me write the range of the second function. So that is range of f of x equals to what? So here, so let's say range of f of x is nothing but the values of this square root of 4 negative x square. Okay, so how do you have to get the range of values for this square root of 4 negative x square? So like when I consider this one square root of, let me write over here, square root of 4 negative x square. To get, since we have, actually it is we have to assume it's a positive square root because we don't have any sign in front of the square root. It's a positive square root. So always its value has to be positive, or it can be 0. So how do you have to decide? How do you have to find the minimum value and maximum value? Because we have to write the interval from minimum value to maximum value for this one. That gives a range of f of x. Okay, so I said either it can be positive or it has to be 0. So 0 is the minimum value because always it's positive. So now I got the minimum value of the range, that is 0. So how do you have to get the maximum value? To get the maximum value, consider the stuff we have inside 4 negative x square. So here, for example, let's quickly find the domain of this square root of 4 negative x square. So domain means the value of x for which this square root of 4 minus x square is defined. So to get domain, just have to consider square root. The value we have inside the square root always has to be positive, or it can even be 0. So when I take this 4 negative x square is greater than or equal to 0, then I'll be getting the interval for x, that is negative 2 to positive 2. So that is, it can be written 4 as 2 square, and like whatever stuff I've done in the previous part. So in the similar way, we have to factor this expression and we have to solve, and so we'll be getting a domain. This is a domain for f of x, I mean for this square root of 4 negative x square. Okay, for example, okay, let me mark these negative 2 and positive 2 on the number line negative 2, positive 2. Let's take some values over here, 0, and here we can have negative 1, here I have positive 1. Okay, when I take x is equal to negative 2, I'm taking the minimum value of x over here. So what will happen? When I take x equals to negative 2 whole square will become 4, 4 negative 4. Anyways, the value of the square root of 4 negative x square becomes 0 when I take x equals to negative 2. When I take x equals to negative 1, so negative 1 whole square will become just 1, then 4 negative 1, which is square root of 3. So square root of 3 is going to be 1.732 approximately. When I take the minimum value, the least value of the domain, so this value becomes 0. When I take the next value, negative 1, its value is greater than 0. And when I take x is equal to 0, the next value, what will happen over here? So it will be square root of 4, which is 2. When I take x equals to 1, again it will become 1.732. When I take the greatest value in the domain, that is 2 square, x will be 2 square. And that is it will become 4 minus 4 is 0. So in this domain from negative 2 to positive 2, so this value can either be 0 or the greatest value is just 2. So that we get greatest value for this stuff when x is equal to 0. So the range of f of x is going to be 0 to 4. That is 0 to 4. Okay, now so let's discuss the range of the composite function. Actually, the range of a composite function can be the same as the range of the second function. In this case, it's this interval 0 to 4. Otherwise, the range of the composite function must lie inside the range of the second function. That is, the range of the composite function has to be the subset of this interval. Okay, so for that we have to get the range of the result of the composite function that we already got over here. So what is the range of this one? So like already we got the domain for this one, that is 4 negative x square the whole square. Its domain is that is negative square root of 2 to positive square root of 2. That is the range of the composite function we got over here. And also like so its values already we know that negative 1.414 approximate, here 1.414. And in the middle we have 0, and here we have you can have negative 1 and positive 1. Okay, so here when you take the minimum value of the domain of this composite function for this x over here, what will happen? So when I take negative square root of 2 for x over here, what will happen? So x square equals to negative square root of 2 the whole square. Then it will become, when I take square for a negative value, it will become positive, and the square root and square will cancel it. I'm just getting 2. So the value of x square is 2. 2 square, when 2 is squared, you get 4. So like, so when I take x equals to negative square root of 2, this x square becomes 2. When 2 square is 4, 4 negative 4 is 0. So when I take the minimum value of the domain of the composite, the least value of the domain of the composite function over here, so I am getting the value of this square root of 4 negative x square whole square is 0. Okay, when I take like negative 1, so I'll be getting, when I take x equals to negative 1, then x square will become just 1. 4 negative 1, square root of 4 negative 1 is just square root of 3, it's 1.732. When I take x equals to 0, this complete stuff will become 0, then square root of 4 is will become 2. So, and also when I take x equals to the greatest value of the domain, square root of 2, what will happen? When I take for square root of 2 for this x square will become 2, and this stuff completely will become 4. 4 minus 4 is 0. So when I plug in the values from the domain of the composite function over here for x, so its minimum value is 0, and we get the minimum value 0 for the least and greatest value of the domain of the composite function. Already we got it, negative square root of 2 to positive square root of 2, and we get the maximum value 2 for this square root of 4 negative x square the whole square when x equals to 0. So the range of this composite function is 0 to 2. Okay, now I got the range of the composite of result of the composite function 0, 2. Already we got the range of the second function f of x 0, 4. As I said already, the range of a composite function has to be the same as the range of the second function, or the range of the composite function must lie inside the range of the second function. That means the range of the composite function has to be a subset of this interval. So how do we have to conclude? Again, we can draw a number line for the range. So this number line represents the range. Let me take a positive infinity, and here I'm taking negative infinity. Okay, now so let me mark so that 0. So here in the result of the range of the composite function is 0, 2, and the range of the second function is 0, 4. So here we have 0, 2, here we have 0, 4. Let's mark all these values over here. So if I take 0 here, then we have 1, we have 2, so 3, and here 4. Okay, first let me draw the result, the range of the result of the composite function, which is 0, 2. So please remember this 0 and 2, both of them are included. So since both of them are included, let me take a filled circle at 0 and filled circle at 2, so 0 to 2. So I have drawn the domain of the result of the, not domain. So the range of the result of the composite function I have drawn 0, 2. Now let me draw the range of the second function 0, 4. And 0 and 4, both of them are included. So let me draw a filled circle at 0 and filled circle at 4. Okay, so this gives the range of the second function. Now, what is the common region of these two graphs? That is clearly this part. So this common region gives the range of the composite function. So this common region is nothing but 0 to 2. So the range of composite function f dot g is 0, 2, or it can also be written as 0 less than or equal to y less than or equal to 2. Usually for range, we use the variable y. So now I got the domain of the composite function f dot g and range of f dot g. So the domain of f dot g, the composite function is negative square root of 2, positive square root of 2. The range of the composite function is 0, 2. Otherwise, we can write them in interval notation.